So this function here is a fifth degree polynomial, so we know it's smooth and continuous. There's no cusps or corners. So let's see what we can do about finding the smooth relative max and relative min. We'll start by finding the derivative. So let's see, we're going to get f prime of x equaling, well, what do we have? 5x to the fourth minus, now I'll do this in parts here. We got 15 halves times 4x cubed, and of course the derivative of that constant is 0. So now we can reduce a little bit. We'll get a 1 and a 2. So here's our derivative. F prime of x is equal to 5x to the fourth minus 30x cubed. And our first question, of course, is where is f prime of x equal to 0? And that gives us smooth maxes, smooth mins, or these terrace points. We just have to use the first derivative test to find out which one we're going to get. So f prime of x equals 0. So f prime, we decided, was 5x to the fourth minus 30x cubed. Put that equal to 0. We can factor out a 5x cubed, and that will leave us with what? An x minus 6 equals 0. So we're going to get two critical values here. We're going to get one at 0, right? That comes from that one. And then we'll get one at 6. So here's our two critical values. So we'll use the first derivative test to determine, what do these give us? Maxes or mins or terrace points. So I'm going to rewrite the derivative up here at the top right where I can easily see it. So this is, what do we get here? We got 5x to the fourth minus 30x cubed, but I like to have it in factored form. So I'm going to factor out that 5x cubed, getting an x minus 6. Now, let's draw our number line. Label it x. And note our two critical values. We've got one at 0 and one here at 6. So let's analyze f prime. We'll do a sign chart here. So, to begin with, pick any number in this leftmost interval, like -1. And if you put -1 back into the derivative, right now the 5 is always going to be positive. Put -1 here and -1 here, and let's look at the signs. So the 5, that's going to be positive always. But at -1, put a -1 here, -1 cubed, that's negative. And then put that -1 here, -1 minus 6, that's still negative. And if I multiply a positive and two negatives together, I end up with a positive, which tells me that in this interval, this function is increasing. So this function is increasing here. Now, let's look at this interval right here between 0 and 6. I'll pick any number, but maybe 1. Pick 1, make it easy. So if I put 1 in all three of these, for all three of these factors, the 5, positive always. If I put in the 1 here, 1 cubed, that's 1, that's positive. And then put in 1, put in our 1 to the 6th. 1 minus 6 is negative. Multiply those together, I get a negative. So the function in this interval is decreasing, so it's decreasing, going down. Now, actually, you know what I think about it? This function over here is increasing. It could have been increasing like this, too. All I know is that it's going up. Right, it's going up. This one's going down. What about this last interval here? From 6 on. From 6 on. Pick a test number like 7. If I put 7 in here, the 5, again, is always positive. Put 7 in for this x, 7 cubed, that's going to be positive. And put in the 7 here, 7 minus 6, that's positive. Make that multiplication, you get a positive. So this function here is increasing, so it's going up. So by the first derivative test, what have we got? On the left of 0, the function goes up. To the right of 0, it goes down. So what do you know about 0? Must have a relative maximum there. And then look at this 6. At the 6, what's happening? Well, to the left, the function's going down. and to the right it's going up, so we must have a relative minimum there. So here's what I'm going to conclude. We're going to have a relative max at 0, and if I put 0 back into the function, just put 0 all the way back into the original function. So if I put 0 in here, 0 in here, I get 0, 0, I'm just left with negative 10. And then we're going to get a relative minimum at 6. Now, we have to put 6 back into this original function. 6 to the 5th minus 15 halves, 6 to the 4th minus 10. So I did that on my calculator, and I got negative 1954. Way down there. All right, so there's my relative max, relative min. So this curve apparently looks something like this. Must come up, hit a max, because it's smooth, and then it goes way down here, hits the min, and then comes back up. You know, I know it does this. I know it goes up like this. It can't go up like this, because if I did that, I'd have one of those corners, and the derivative does not exist. But this is a polynomial, which are always smooth.